which we have as a tradition to introduce the topic and some of the terms that might be used as we move forward. So Dr. Yi Yin is a research scientist. She continues to be affiliated with the research faculty at Caltech and now on the faculty at NYU. And what we're always examining is, of course, the major problem of the increased temperatures on planet Earth and how dramatic that has been since the 1980s. So this chart is just to remind us that, you know, if there were any trends before World War II, it was actually towards some cooling effect. So this is what we call anthropogenic climate change. This is a climate change that has been produced by human activity and not by longer-term natural cycles. This is our fair city on a bad day. Maybe we've made some improvement in air quality in Los Angeles thanks to air pollution standards and changes in vehicle emissions and so on, but we still are the most air polluted city in the United States for a large metropolitan area. This Washington Post article actually looks at the case of Kolkata in India. I recommend it because it also has very useful visual representation of concepts that people dealing with urban development and the science of urban planning take into account when it comes to very high temperatures experienced by, in this case, the poorest people in the city of Kolkata. This article is one that deals with the urban heat island effect in a completely different context, but I thought I would mention that Dr. Yin is actually part of a global effort by environmental scientists to get more, what is the term that's used, granular in terms of the data and in terms of what can be done when it comes to public policy outcomes. So the heat island effect, what you're seeing here is essentially what we all experience when we drive downtown. It's often hotter. There are dark surfaces, there's asphalt, there is rooftops that are tarred, so that the heat absorption by automobiles and buildings makes the urban core considerably warmer than the more forested, if you want to use that term, suburban areas, and of course the more the wilderness areas or undeveloped areas outside the city.
The majority of Americans live on islands. They're just not the usual kind of islands that you're thinking of. They're urban heat islands.
What's happening is heat is literally getting trapped in this urban center. So if you can think of a dome overarching the city, all the carbon emissions, whether from the buildings, from all the people within it, or just traffic, that plus air getting trapped within the tall buildings and the narrowly placed buildings, all of that is building and building, and it has nowhere to escape. A New York-based study that measured temperatures between the South Bronx and Central Park, and there was a 20-degree difference during the daytime. The difference can be as far as 22 degrees Fahrenheit, even at nighttime.
So the big question will be adaptation. Do city planners really start thinking about what they need to do to make cities more livable as temperatures are rising?
There's really almost three ways of doing it. One is literally planting more trees, creating more urban gardens, creating green spaces. And the other then is to look at how do we either retrofit buildings, create living rooftops, paint the colors of the rooftops white. And then the third is really helping communities when there's a heat wave coming, to alert those communities, but also to be able to respond, whether it's providing water, whether it's checking in on people, and just taking care of people.
It's a huge menu, and too many places are looking for the one thing they want to order, when it's really like, let's get one of everything and try it out.
So what we're looking at is this bridge between science-based public policy, or this bridge between the scientific community and scientific research and the outcomes, which would be solutions to environmental problems that happen, of course, across the board in society. But in this case, we're very interested in what local, county, and state of California can do to address the particular heat island problems of the city of Los Angeles. Dr. Yin is, as I mentioned, now very fortunately at New York University, and her focus is on the complex interplay of carbon, water, and energy between Earth surfaces and the atmosphere. So this combines atmospheric sciences with chemistry. As most things in environmental studies and environmental science, it's multidisciplinary. That is, you gather data using different methods and optics and put them together in a cogent observation, statement, conclusions that bring in all those different sources of data. So the paper that was published by Caltech is called Low Income Areas Experience Hotter Temperatures in LA County. This paper we've posted on our website, and I hope that people will visit that. You can see the address of our website right behind Beth Abels and myself. And you'll also notice that it encourages you faculty to fill out a survey that we've been undertaking now for 2 months on your experiences with the SEI and what you would like to see us doing moving forward. So it came out April 28th. It's a recent article, and it has really, well, I hate to say caused a big splash, but it has. And there are, as you can see, quite a few researchers that took part in this research article. I recommend to my students in environmental science to not be intimidated by scientific papers. We actually spend one semester in my lab class adopting one science paper per student, and students learn to get over their fear of science papers, learning that they are actually very well structured. They have a certain method to them that makes taking them apart easier than anything we do in social sciences and humanities. So I do encourage people to have a look at this paper and maybe even include it in your course materials as you discuss Los Angeles. So this is the most compelling of all of the images that are in that paper, and you can see that, as usual, a picture speaks 1,000 words. So at the very top, you see this correlation with income, the median household income. And then on the bottom, you can see what are the spatial patterns and correlations. And this has to do with land surface temperatures, with income, and with vegetation. So that is why these three maps are quite distinct. And then you can see the use of color to highlight those contrasts between the urban core and, of course, the very hot areas up in Lancaster and Palmdale. You have the very hot land surface temperatures. But it is something that, because it's visually represented, is useful even to those of us who are lay people and do not have doctoral degrees in environmental science. So land surface temperature is something that Dr. Yin will talk about. And NDVI is the normalized difference vegetation index. It's a mouthful, but think plants and the role that vegetation plays in cooling areas off. We've had in previous seminars tree people discuss with us the need to plant trees in those neighborhoods that have no trees at all and what difference that makes to the quality of life. The albedo is what is reflected by the Earth as a whole. You could call it the shininess of the Earth if you're taking physical geography. More locally, you're talking about the reflectivity of local surfaces of a body or a surface. So that is something that Dr. Yin will actually refer to. And then you can see these are the once again, looks overwhelming, but it's not. It's actually quite simple. Day and night differences in the seasonal distribution. And then it goes on to discuss household income. So this is the correlating and very compelling correlation of income and what people experience in terms of their quality of life. So this is the hottest year of the hottest year of the hottest year. We seem to break every record every month. And there I will let Yi Yin speak to us all about her work and why we need to use this kind of work when we devise new public policies.